Hello all, we're going to finish up our lessons from chapters 1 and 2 with 2 days on scientific notation. Today we're going to start by talking about how to write numbers in scientific notation. So make sure you've got your notes packet open to this page and let's get started. So let's first review what scientific notation is. Scientific notation will always take the form of a decimal where the first digit is always going to be 1 through 9, so there's only one number in that space, followed by some other, however many you need, times 10 to some power. Now, this base here is always going to be 10, and the exponent is going to be the number of spaces that you've jumped in your decimal. So if you remember this from previous years, is that if you have a very large number, like what you see in 1a here, that means that you are going to have a positive exponent for large numbers, and you will have a negative exponent for numbers that are very, very small, like this one in part B. And this is scientific notation is a way that we can write really, really big numbers and really, really small numbers without having to put a ton of zeros afterwards or before. If you have never seen scientific notation, I strongly recommend that you set up a meeting because I am teaching this lesson as if you have seen this before. Now, when we turn numbers into scientific notation, if we take this very large number, the first thing you want to do is say, well, since we know we want a decimal point here where we have just one number in front of it, I know looking at this number here, I want my decimal point to be right here after the 3, because that's only one number in front of the decimal. The decimal point is currently all the way at the end. We don't even write it because it's all the way back there. So the first thing we're going to do is count how many spaces we'd have to move that decimal to end up right after the 3. So there's 3 spaces, another 3, one more, so I move the decimal point 10 spaces. This is then our exponent. Our decimal is 3.06, and I can stop it there because everything else is just a 0. And so putting 60000 doesn't actually change the value of the number. And then we say times 10, which is always going to be the base here, and 10 spaces is the exponent, and it's going to be positive since we started with a very large number. Now with our second one, if we have a very small number, we're still going to say, okay, here's the decimal point currently. We want it to be after the 4 because we want that one digit in front of the decimal point. Now it's a little bit harder to count our spaces here, but we're going to try going 1, 2, 3, 4, 5, 6. So that's 6 spaces. So our decimal is 4 and then 52, because those are the rest of the digits, times 10, which is always the base, and then 6 is the exponent, and in this case it's a very small number, so it's negative 6 spaces. So that's how you turn very large numbers and very small numbers into scientific notation. Sometimes you will have a number like this, which looks like it's in scientific notation, but it's not quite, and so we have to change it a little bit. If we look here, we notice that the decimal point is behind the 5, where we want it to be behind the 3. So we want to move it 2 spaces. Now, since we know that this number is bigger, 325.6 is bigger than the number that we want in our scientific notation, that means that we're going to add those 2 to our exponent. Because remember, spaces are the same as the exponent. We plug that in there. So when we rewrite this number in scientific notation, 3.256 is our new decimal, times 10 to the 5 plus 2 for those additional 2 spaces we had to move the decimal point. So our final answer is 3.256 times 10 to the 7th. Something else you might have to do is expand this back into standard form. So for example, if I'm looking at this number here, 5.4 times 10 to the 6th in scientific notation. What this tells me is I need to take this decimal and move it 6 spaces. And since it's positive, we're going to move it 6 spaces to the right to make it a large number. So in this case, we've got 5.4, and then for every space we move, if it's empty, we put a 0 in. So that's 2 spaces, 3, 4, 5, and 6 as the place our decimal ends up. And we fill in all those spaces with zeros that are empty. And to write out that final number, it is normal to add the commas every 3 digits, like that. And so our final answer is 5,400,000 as the expanded standard form of scientific notation. Here, the number is too small, so we've got a negative, so we're going to take our decimal and we're going to move it 2 spaces to the left to make it a small number. So once again, we are going to fill in those blank spaces with zeros, leaving the numbers that are there, and we end up with the standard answer as 0.0302. You might use scientific notation to solve problems because it's a nice way to write really large numbers. So for example here, find the height of a penny is 1.55 millimeters thick. Find the height of $1,000 worth of pennies. So for every penny that we put into this tower, we have 1.55 millimeters, and it's $1,000. So it's $1,000, and for every dollar, that is 100 pennies. So this is how you would set up the actual height. So here's our number of dollars, and then pennies per dollar. So instead of multiplying this out into one very large number, I'm going to use scientific notation. I'm going to say 1.55 times, this is 10 to the third and 10 to the second, so I can simplify this down in scientific notation as 10 to the 1, 2, 3, 4, 5 fifth millimeters. And it's just a nice way to simplify a more complicated problem. You can also do similar things in reverse. If a stack of pennies is 46,500 millimeters tall, how much money is it worth? Well, we just looked at our previous one, where we said 1.55 times the number of dollars times 100 was equal to the height. Now we just, instead of knowing the number of dollars, we know this variable. And in order to find that, we're finding a variable so that is being multiplied, so we divide by 100, which would cancel out this. That cancels out very nicely here. And we also want to then divide by 1.55 to get our variable by itself. And we can calculate 465 divided by 0.55. You can use a calculator for this one. I will allow that. And you end up with 300 as our dollars. And then always make sure you're including a unit in your word problems. Again, this is a little bit of a longer video, so please leave me any questions that you have in the comments or set up a meeting, and I'll talk to you later.